Hi, welcome to this session on Introduction to Semiconductor Diode. I am Subodh Raj, Assistant Professor in Electronics and Communication Engineering at Sahadaya College of Engineering and Technology, Kerala. Today, in this session, we will discuss what a semiconductor diode is, and we will see certain aspects of the semiconductor diode which include diode biasing, diode current, and diode characteristics. So by the end of this session, you will be familiar with what a semiconductor diode is, and you will be familiar with some of the aspects of the semiconductor diode. Let us start our discussion. So what is a semiconductor diode? So a semiconductor diode is a PN junction device. If you fuse a p-type material which is rich with holes with an n-type material which is rich with electrons, a junction formation occurs, and this gives rise to a PN junction diode. If you take a lead out of the p-type of the diode, it is called the anode of the diode, and if you take a lead out of the n-type, it is known as the cathode of the diode. Since there is high concentration of holes in the p-type and high concentration of electrons in the n-type, there is a tendency for these charge carriers to diffuse to the region of lower concentration. So holes will diffuse from p-type to n-type, and electrons will diffuse from n-type to p-type. But this process will not last long. Due to this diffusion, there is some amount of current generated. But what happens is that during this diffusion process, the holes and the electrons will combine at the junction, and electron-hole pairs are formed. And this electron-hole pairs will give rise to a potential barrier. This potential barrier is commonly referred to as depletion region. So once the depletion region formation is over, for any charge carrier to move across the junction, they should have sufficient energy in order to overcome the barrier potential. This can be achieved only by means of an external energy source. If you do not supply any external energy source, then the movement of electrons and holes across the junction by means of diffusion fades out gradually. The symbol of a PN junction diode is shown. The p-type is represented using a triangle, and the n-type is represented using a line. So obviously this will correspond to the anode, and this will correspond to the cathode, because this is taken from the p-type and this is taken from the n-type. Now we will see what is meant by biasing of a diode. Any PN junction diode can be biased in two ways, the forward biasing and the reverse biasing. We say a PN junction diode is forward biased when the anode is connected to the positive of a supply and the cathode is connected to the negative of the supply. In this case, we say current flows through the diode, which means the diode is conducting. On the other hand, when the anode is connected to the negative of a supply and the cathode is connected to the positive of a supply, we say the diode is in reverse bias conditions and there is no current flow through the diode. But simply connecting any voltage source in this particular fashion in order to forward bias the diode is not enough. You should make sure that the applied voltage is sufficient enough to energize the charge carrier from both P region and N region, and this voltage should enable these charge carriers to cross the barrier. Then only there will be current flow through the diode. And the minimum amount of voltage that is required to make current flow through the diode is referred to as cut-in voltage. It is represented usually using the symbol V suffix gamma. For a silicon diode, the value of cut-in voltage is 0.7 volt, and for germanium diode, the value of cut-in voltage is 0.3 volt. The diode has a unique property. It allows current flow only in one direction and blocks the current flow in opposite direction. So let us consider this particular diagram in which there is a PN junction diode and the depletion region formation has happened. We have already applied an external voltage Vd, but there is no flow of current indicated. But you do one thing, you go on increasing the value of Vd so that the value of Vd is greater than the cut-in voltage, V gamma. So at this particular point, what happens is that the depletion region width reduces and charge carriers from both p-type and n-type will start moving across the junction. And as you know, when there is movement of electrons in the opposite direction, there will be current flow. So current flow will occur as shown in the figure. The current that is generated or that flows through a diode is represented using ID, and it is given as the product of IS to e raised to Vd by nVt minus 1, where Id is the diode current, Is is the reverse saturation current. We will see what is reverse saturation current in a moment. And Vt is a thermal voltage whose typical value is 26 millivolt at room temperature. The value of N is equal to 1 for integrated circuit diode and 2 for discrete diode, and Vd is the applied voltage. So if the value of Vd is greater than cut-in voltage, you have current flow. Id will be greater than 0. And if the value of Vd is less than cut-in voltage, the current flow is 0. Other way we can say the diode is open circuit, or the diode is in reverse bias condition. Let us see the characteristics of a diode. The characteristic of a diode can be divided into three regions. First one is a forward bias region, the second one is a reverse bias region, and the last one is a breakdown region. So the characteristics will tell you the relation between the input applied voltage Vd and the diode current Id. As you can see, when the applied voltage is very small in the forward direction, there is little current flowing through the diode. But when the applied voltage reaches or becomes greater than the cut-in voltage V gamma, there is large amount of current flowing. Why? Because when the applied voltage Vd is greater than V gamma, this particular term, the exponential term, becomes a large quantity, and when you multiply Is with a large quantity, you will get large amount of Id. On the other hand, when you go on increasing the reverse applied voltage in the negative direction, what happens? This particular terms approximates to 0, and the value of Id will be approximately equal to minus Is. And this Is is known as the reverse saturation current or the reverse leakage current, the magnitude of which is very small. But you can see when the applied reverse voltage reaches a particular value, there is large amount of reverse current flowing through the diode. This happens because of the phenomenon of breakdown. Breakdown can happen in a diode in two forms: avalanche breakdown and Zener breakdown. Whatever is the breakdown occurring, if the diode breakdown occurs for a fixed voltage, then such diodes that operate under such conditions is known as Zener diodes. Zener diodes, due to this particular property, is applicable in applications such as voltage regulators. But our ordinary diodes, which is commonly known as signal diodes, if used under such conditions, will break down completely and they get damaged. We cannot use them anymore. So let us see what all things we have discussed today in this session. We have seen the structure of semiconductor diode. We saw the basic operation of semiconductor diode. We saw the diode current relations. We familiarized with some of the terms which comes in the diode current equation, and finally we discussed about the diode characteristics. Hope you had a good time watching this particular video. This is for this particular session. Thank you.